Welcome to the chemistry question. Jordan here, and today we're talking about cobalt. Cobalt, element number 27, is a transition metal situated between iron and nickel. Like iron and nickel, it is ferromagnetic, meaning it is strongly attracted to a magnet. Cobalt-60 is a radioactive isotope of cobalt present in nuclear fallout, which sometimes gives cobalt a bad name, whereas its one naturally occurring isotope, cobalt-59, is perfectly stable. Cobalt is never found as a free metal in nature, though its ores are fairly common and have been used throughout history as blue pigments. One of my favorite compounds is Cobalt-2 chloride, which in anhydrous form is a lovely shade of blue, but when exposed to moisture, it forms Cobalt-2 chloride hexahydrate, which is a pretty magenta. This process is reversible, and therefore Cobalt-2 chloride makes an excellent humidity detector. The main reason I chose to do a video on cobalt, however, is so I can explain a project I'm working on in my chemistry lab that I find really fascinating. This project involves synthesizing tris-acetyl-acetonato cobalt-3, and this is one of those rare cases where something is easier done than said. This is why in lab we call it cobalt-3 ACAC. In order to synthesize this chemical, we took cobalt-2 carbonate and reacted it with acetyl-acetone. Acetyl-acetone acts as a weak acid in solution, and its conjugate base, acetylacetonate, is a ligand, which means it can bond to metals. This reaction produces carbon dioxide, water, and tris-acetyl-acetonato cobalt-2, which has the same structure and formula as cobalt-3 ACAC, but has an extra electron and forms an ion, as seen here in a compound with sodium. To get rid of the extra electron, we must further oxidize the cobalt from cobalt-2 to cobalt-3. Cobalt-3 compounds are known to be less stable than cobalt-2 compounds. However, the structure formed by the 3-acetylacetonate ligand stabilizes that oxidation state. We oxidize the products by adding hydrogen peroxide, a moderately strong oxidizer. We knew a reaction took place because the solution changed from the pink color of cobalt-2 carbonate to a much darker green, the color of cobalt-3 ACAC. Thus, we were left with the desired products. However, it had not yet been tried, so instead of looking like a nice dark green color, it looks like some weird spinach drink you might find at a health food store, and I suspect the two are about equally as drinkable. Thank you for watching the chemistry question. Be sure to subscribe and leave any questions or suggestions in the comments below. Until next time.